Alright, so in this video we're going to talk about how to traverse nested data structures in Python. And so this is a really important skill for when you're executing API calls in Python. And if you don't know what an API call is, uh, I'll give you the basic rundown. But basically, most major websites that you can browse to also have what's known as an API. Now, this API is sort of like an alternate interface that returns raw data, not in the visual format, but in a serialized, standardized format, right? So APIs use HTTP just like you do in your browser, right? But when you get that raw data back, typically you're going to get a large nested data structure. And if you're executing this API call in a Python script, you might not be able to look at it visually. And so in this video, we're going to talk about how we can look at some return data in the terminal and really get familiar with the different nested data structures that you might see. And also when I say data structures, what I really mean is really just lists and dictionaries. That's mostly what you're going to see. So you're going to have things like lists of dictionaries or lists of lists, dictionaries with keys that have a value of a list, etc. So basically, and these can get pretty hairy. A lot of these nested data structures that you get back from an API call are going to have several levels. So it really helps to be able to traverse that in the dark, so to speak. And so for the video, I've gone ahead and created a basic script here. So it's called nestedobjects.py. And what I've done is I've just defined 4 variables, x1 through 4. And each one of these has a nested data structure that gets progressively more complicated. So for the first 2, we'll actually look at it in a Python terminal and kind of figure out some good tricks for navigating through it. And then for x3 and 4, we'll just analyze the data structure itself, and then we'll look at some handy ways of actually printing them out on the command line in a really nice formatted way. So start off with exercise 1. We can see right off the bat that x1 is a list because of this opening bracket. And then if we look inside the list, it's actually a list of dictionaries. So we have 2 dictionaries here. The first one is right here, and the second one is right here, and they're separated by the lone comma. And each one of these dictionaries represents one person. So this first dictionary has the first name key, last name key, and the age, and the same thing with the second dictionary. And this is a really common pattern you'll see in the return data of an API call. Typically, you'll see a list of dictionaries where each dictionary represents an instance of an object. So in this case, it's just a person, right? So now let's actually look at it in a Python terminal. So what I'm going to do is I'm going to run the script interactively. So on the command line, I'll say python-i for interactive, and then nestedobjects.py. And so what that does is it's going to run our whole script for us, but at the end, it's going to open a Python terminal so that we have access to our data still. So typically the first thing you're going to do when you have some sort of return data from an API is we're going to use the type built-in function to figure out what we're working with. So we'll just say type x1. And so that tells us it is in fact a list. Typically if you run into a list, or typically what I like to do is isolate the first item of that list to kind of get an idea of what each one of those items has, right? If we're making an API call and we get a list of anything, typically, not always, but typically every item in that list is going to be the same type of object with the same basic keys or items in a list. So in this case, we can kind of assume that every item in the x1 list is the same. So, and again, we're doing this assuming that we don't have this in a graphical format like we actually do. We're assuming that we're working in the dark. So let's go ahead and isolate the first item of our x1 list. So we'll just say item is equal to x1 with a 0 index because it's a list. And so now let's look at the type of item. And that is a dictionary. So if we run into a dictionary, typically what you want to do is just look at the keys. So we'll say item.keys. And you can see we have the first name, last name, and age. And that's basically all there is to it. Let's move on to exercise 2. We'll go ahead and break it down. So exercise 2 is a dictionary, so we have the opening curly brace. And then at the root level of our dictionary, we have 4 keys. We have count, next, and previous, which are pretty simple. Next and previous just have a value of none. Count is 4. This is also a pretty common thing you'll see in API calls. Typically, you're receiving a set of objects and their attributes. And typically, at the root level, you'll see a key called count or number or something along those lines, telling you how many results you got back in total. So this is telling us that we have 4 objects somewhere in our results. And in fact, if we go to the results key, we can see that that is equal to a list. And here is our list of dictionaries. Now in this case, each one of these dictionaries actually represents a network device. So you can see for the first one, the name is Orco Site 1 Red Router. We have the model and the serial number, and then the same keys for each one of the following device objects. So again, this is the first device, second device, third device, and fourth device. And so that's exercise 2. Let's actually look at it in the terminal. So we'll say type x2. It's a dictionary, so let's go ahead and look at the keys. So if let's say hypothetically you just executed an API call in a Python script. The count is nice and all, but typically we just want to get to the results because we're looking for something specifically. So let's take a look at results. We can even save that to a variable. So we'll say data is equal to x2 results. And then let's look at the type. So what this is saying is that the results key has a value of something, and that something has a type of a list. So results is a list, essentially. So since it's a list, let's go ahead and isolate the first item in the list. And we'll just say items equal to data 0. And we'll print it out just for fun, but let's do type item. So item is a dictionary, so we can say item.keys, name, model, and serial number. So if we were looking for the serial number, we then know from the root level, we could say x2 results, and then 0 because that was a list, and then we can say serial number like that. And that's how from the root level we could pull that same piece of information. But when you're drilling down into the data, it helps to isolate, when you run into a list, it helps to isolate that first item. That way you're not having to type out this whole long string of things whenever you want to reference something that's deep in the nested tree. And that's the basics of really traversing a nested data structure on the command line. So now I'm going to show you a couple handy ways of actually printing it out on the terminal. So the first option you have is the pretty print module. So what we're going to do is we're going to say from pprint import pprint. So what this is saying is from the pprint package, import the pprint module. And so now what we can say instead of we could just say print and then x2 like that, and it's just not formatted. But to use pretty print, we just say pprint and x2. And you can see this is a little bit better, but it's still not perfect. A better method is to use the JSON module. So I'll show you what it looks like, but we're going to say print JSON. Oh, I'm sorry, we got to import it first. So first we'll say import JSON, and then we'll say print JSON, and then the JSON module has a function called dump string, or dumps for short. So what this does is it's actually going to output a JSON formatted string. So if you haven't seen JSON before, just know that it looks almost exactly like Python. So JSON is going to contain lists and dictionaries, and those dictionaries are going to contain primitive data types like strings, integers, and booleans. Now JSON looks virtually the same as Python lists and dictionaries, but there are just some formatting differences. So JSON is not as forgiving when it comes to formatting. For example, in JSON, we can't have single quotes. We have to use double quotes. Also, if we're making a list, we can't have an extra trailing comma after the last item in our list. So for example, in Python, I could make a list, call it my list. I can say 1, 2, 3, and then I can have a trailing comma at the end, and Python doesn't care. But that would be invalid syntax in JSON. But anyways, besides some minor formatting differences, JSON and Python lists and dictionaries look virtually the same. So the JSON dump string method actually outputs a long string in a JSON format, but when we print out that string, it looks just like Python anyway, so it sort of gets the job done. So what we'll say, just to kind of show you what it looks like raw, we'll say json.dumps, again that stands for dump string. The first argument it's going to take is the object we want to print, so we'll just say x. Let's do x3. And then the second argument it takes is the indentation level. So in JSON, similar to Python, the standard indentation level is 4 spaces, so we'll stick with that. We'll say indent equals 4. We'll close out that function. And you can see we actually get this whole long string, but if you notice, we have some new line characters, and then we actually have some indents, and in here should be 4 spaces. And on the levels where there's deeper indentation, you'll have 8, 12, 16, so on and so forth. So this is our string, but if we pass this to the print function, it'll actually print it in a pretty way. So let's wrap that in a print function, just like that. And now if we hit enter, you can see it looks just like what we have up in our script, right? We have that pretty format. And so again, you can use pretty print, but JSON, that dump string method works a lot better. So now let's just look at exercise 3 visually to kind of get an idea of what's going on here. So at the root level, exercise 3 is a dictionary because we have that opening curly brace. And then if we scroll down, it only has one key, and that key is called data. And data has a value of another dictionary. Now this dictionary has one key called devices, and that's it, so one key. The value of this key is a list. Now, just using common sense, we have devices, which is equal to a list, so safe to say this is a list of devices. And in a similar fashion, we actually have one single device represented by this entire dictionary, but this is one item in the devices list, right? We don't have any trailing commas, we have no other items. So now if we look at that device dictionary, we can see some keys at the root level of that device, so the name, model, serial number, and then at the very end we have the interfaces key, which the value is a dictionary. And then inside that dictionary we have 4 keys. We have one called 0/1, 2, 3, and 4, each representing the interfaces of a Cisco device, for example. And then each one of those interfaces, which is just a key, has a value of a whole dictionary representing that interface. And then each interface has a few keys like the type, address, mask, and whether or not it's enabled. So that's exercise 3, and we'll look at exercise 4, and we'll close this out. So exercise 4 is a dictionary which has one key called data, and then this data dictionary, because it's an opening curly brace, has one key called sites, which is a list. And again, it's probably a list of sites represented by dictionaries. So here in the sites list, we actually have 2 sites. So the first one is this whole block of code right there, right? So we have the opening and closing curly braces, our comma, and then the second site, which is from here to here. Then each site has the name, its location, and then we have a devices key, which is just a list of devices. And this is actually the same format as the data in exercise 2 rather. So again, this is a good skill to have, because when you're making API calls, primarily you're going to get these really large nested data structures, and they go deep. They have many layers. So again, if you're traversing it on the command line, typically you want to find out what type of data you're working with first. So use that type built-in function. If you run into a list, it can be helpful to isolate the first or any one of those items from the list, and then analyze that specifically. And if you run into a dictionary, typically what you want to do is just look at the keys using that .keys method. And that's really all there is to it. I appreciate you watching, and I hope you have a good one.